objectives were implementation analysis of moving average filter, implementation and analysis of finite impulse response filter, Fourier transform design method. These are tasks on which we have theory questions where definition filters are used to extract, enhance or suppress specific components of a signal based on their frequency, amplitude or their phase properties. Then we have types of filters. We have low pass filter, high pass filter, band pass filter and band stop filter, all pass filter. What I tend means parameter filter, step response, then overshoot and linear phase. Frequency domain roll off, ripple in passband and post stop band attenuation. Discuss the role of low pass filter for filter designing. This is the role of low pass filter and filter design includes selective desired frequencies while blocking their high frequencies, preventing aliasing in digital signal processing. Asked to plot a signal in time, frequency and domain along with its magnitude. This is our source code where we have given the values to x, then using plot the signal in the time domain command, then plotting using the FFT command we have computed its Fourier transform, then plotting its magnitude. This is the output where first figure is showing signal in time domain, then in magnitude response and then signal and frequency domain. In the next one the value of x is varying. First of all I have defined the value to x, then by using the plot command I have plotted our figure, then computing the FFT as in the given as in the last task. The same process is this is our next code where we have value of x of 121, maximum 61. Again we define the value to the x, then plotted our signal, then again computed FFT and then computed magnitude response and then plotted in frequency domain. Now moving on to output. This is output signal in time domain, magnitude response and in frequency domain. The next one the value of x is again varying in the same code has been used, just value of x has been changed. Again here its noise has been added. The next task we have given apply three tabs symmetrically around moving average filters in the next noise and observe the time and frequency domain parameters. Here we have to observe the time and domain frequency parameters of a filter. First of all I gave the value to the x and then defined the moving average filter coefficients, added noise, applied the moving average filter to the x noise and then plotted the signal in time domain. Then again I computed the FFT, then again computed the magnitude response and plotted our signal. Following is output filtered signal in time domain, magnitude response of the filtered signal and filtered signal in frequency domain. Apply 11 tabs symmetrically around moving average filter on signal x noise and observe the time and frequency domain parameters. Here again given the value to the x, added noise, then moving filter counted moving average filter coefficients, then plotted the signal, the same output, and the output is this filtered signal in time domain, magnitude response and in frequency domain. Again we have to use the same code but only the values have been changed. Repeat example 7.2. We have given the example 7.2 for time domain coefficient. Here we have to use its MATLAB code. The following is output of magnitude frequency response. Again we put it example 7.2 for 51 tab coefficients. These are the filter coefficients. This one is the transfer function, difference equation, and here is magnitude frequency response. Again repeat example 7.2. These are its coefficients and this one is its magnitude response. Apply the filters made in a part to the signal observe the changes for signal x in time and frequency domain while varying the number of coefficients of the filter. First of all I have used the sampling frequency, time, x1, x2, signals have been defined and then plotted the original signal in time domain and I plotted the original signal in frequency domain, and then I found their number of coefficients. Here is its output. Original signal in time domain, original signal frequency domain, and filtered signal 17 coefficients in time domain and then in frequency domain. Here I have repeated the example 7.3 with 7 tap and 17 tap. This one is output on the 17 tap FIR bandpass filter, and this one is output with original signal in time domain, original signal frequency domain, and FIR bandpass filter and FIR 5 tap bandpass filter. Thank you. This was from lab number 8. Allah Hafiz.